Okay.
So, Amy, how are you doing?
I'm good, thank you. How are you?
Very good, very good. So, we had some problem with internet. Now it's, I think, perfectly fine. So, let's hope for the best.
Mhm. Yeah.
Now, we have been working on calculus. We did some differentiation, some integration. How do you figure it out? Is it okay for you?
Yeah, it's making a lot of sense. So, yeah, there were a few questions that I didn't get, but I sent them to you. So,
Yeah.
yeah.
So, I actually looked into those questions. They are kind of tricky. I should say they are kind of examination questions which sometimes mislead you. In a
Mm.
way, we will understand how when we go through the examples. So, but basically, you have good concepts of finding area between the curves. So, in integration, we learned how to find area between the curves. Well, curve
Mm-hmm.
could be a function, and then function and x-axis. X-axis is also a curve, a straight line. So, when you find integral, you are basically finding area between the function and the x-axis. So, remember that part.
Hmm. Yeah.
Now, if the function is negative, then the area, I should not say area, the integral is negative. And if the part of the function graph is above the x-axis, the integral is positive.
Hmm.
Now, total integral really means the sum of these positives and negatives. So, depending on what the case is, you get a value. So, this value could be positive or negative. However, when we are trying to find area between the curves, area is always positive.
Hmm.
So you have to break down the integral into small components, and then you have to add the absolute value of the integral to find the total area. That's the whole concept.
Right.
Also, remember that when we have two functions, then in the questions which I saw, they are not really asking you the area between the two functions graph. They add up the x-axis also. So think about three functions when you are working with those questions, right? So you have
All
function
right.
f of x, you have function g of x, and you have the x-axis. And I picked a few related examples which should help you solve your own questions, right? So,
Okay.
purposely, I did not take exactly your questions because I want you to really try
Solve
and
it.
get those solutions yourself, right? So,
Yeah, I'm
kind
glad
of,
though, because
yeah, I'll provide you the method of doing it, and I'll also give you solution in short so that you just get the hint for doing the questions. Will not work into details of finding points of intersections and all those things because those you know fairly well, correct? That's the whole
yeah.
idea, right? So I hope that helps, right? So let me
Mhm.
share with you what I have prepared. Here are four examples, right? So based on what all information I got from you, here are these four examples. So question number 1 to 4. Now I've sketched the graphs on the side and actually provided you with most of the information which you need to solve the question. However, in examination type of questions, you are not given all the information. You are only
Mhm.
given information about the equation of two functions. So you have to always find point of intersection between the two functions, right? So equate f of x
Mhm.
equals to g of x, find point of intersection, and then also find the x intercepts. So for both the functions, find the x intercepts. Label your
Mhm.
graph. So this is going to be your essential step when you begin solving such questions, correct? So
Right.
in most of my cases, especially moving to question number 3 and 4, I have given you all the points, right? But in the first question, I think we have done some calculations just to get the ball rolling. That's the whole idea. So let's
Right.
begin with question number 1, which is given graph of f of x equals to x squared minus 6x plus 5 and g of x equals to x minus 1, find the area of region enclosed by f of x, g of x, and the x-axis. So do you see this term and the x-axis, right? So we have
Mhm.
shaded that region in orange in this particular graph, as you can very clearly see, correct? Now, definitely, it is not the area between the two functions as it does not include this portion. Do you see that? It
Right. Yeah.
includes the portion above the x-axis, right? And the one which is in orange, right? So that is what the area is. Now, if you think about it, what you could also do is see how we are breaking down and solving the question very easily. So without much integration, I mean, without involving both the functions to that extent, right? So in such a question, definitely you will find these 2 points, which are the x-intercepts, right? And the point of intersection, if not given to you. So find these points. Now look here, we're looking into this orange portion. So what I can do here is I can drop a perpendicular from the point of intersection to the x-axis. So what I have is a triangle which includes the green and the orange part. Do you see that?
Right. Yeah.
Area of triangle is half base into height. So we have an area of a triangle here, and area of the triangle is half of, let's say, base times height. Is it clear to you? So we have a big triangle now. So what I will do is that from that big triangle, I'll take away the green area. Green area is the area under the function parabola f of x from this point to this point. Do you understand? So I'm only going to consider the f of x, the parabola, and find the area which is between the x-intercept and the point of intersection, the green area that I'm trying to show you, correct? So total area half base into height, that triangle minus the green area is the orange area. You understand the concept now?
Right, yeah.
That is going to be our approach to solve this particular question. And many questions which you had some difficulty with will follow similar approach, okay? So now, let's look into this solution and then we'll discuss the others, okay?
Was that perpendicular line given in the question? Or do you... Was that perpendicular line given in the question, or did you put it in?
I put it. It was not given.
So in the exam, I have to know to do that.
Correct. So in the exam, they will only give you this orange part, right? They will only give you this shaded portion. They want area of this shaded portion, the orange part. So that is the construction. So I'll say first step will be drop perpendicular. Is that clear to you? In this case, it is CD. So once you have that perpendicular, then you take away the area of this particular curve between x-axis and this particular curve in this region, correct? From the bigger triangle, correct? So let's see how to solve this. Yeah, let's see how to solve this. So here is the solution, slightly enlarged view. Now again, the question here is, given graph of f of x equals to x squared minus 6x plus 5 and g of x equals to x minus 1, find the area of region enclosed by f of x, g of x, and the x-axis shaded in orange. I've written all this in purpose, so that's very clear what am I saying here. Is that clear to you?
Yeah.
So normally, you know, they normally shade in your case, so you know exactly this is the area. Okay, now find these x-intercepts and the point of intersection. That is a basic thing. So find the point of intersection. Then let D be the projection of C on the x-axis as shown. Then you just project this point down, so you have a perpendicular line, right? So you know the x and y values. So let's begin with finding the x-intercepts for the parabola. It is factored form. So you get x value is 1, y value is 5. So these are the two x-intercepts. Now let's find the point of intersection between the straight line and the parabola. Equating f of x equals to g of x, bring the terms on one side, factor, and solve. So you get two values, x equals to 1 and x equals to 6. So we are interested in x equals to 6, which is on the right hand side, shown here. So at 6, you can find the value, y value, using the line. It is much simpler. So when you substitute 6 minus 1, is 5 for you. So you get the coordinates for point C, which is 6, 5. Clear? 6, 5 means the x value here is 6. So we got all the important values. So we have one value which is 1 here, the other one is 5, and this is 6, correct? So clearly, area of the triangle, so big area, which is including the green area for us, orange and green, so total. So A1 is area between the graph g of x and x-axis and the triangle ACD, right? So we are now working out the area of this particular triangle green area. Is that clear to you? So that is my A1, half base into height. Clearly base is between 5 and 6, which is 6 minus 5. And the height is y value of C, correct? Since the C is 6, 5, height is 5. So we know that particular height here is 5. So you multiply that and you get the area of the function, the green area, which is 25 by 2. Now, we have, so that is, we have found the.
Is that the big triangle?
Oh yeah, big, I'm sorry. Big triangle, yeah. From 1 to, yeah, 6 to 1. And 5 was the height, so big triangle, right, correct. So A1 is the area of the big triangle, let's be very clear about it. So that is A1, full area. Now we will consider the area which is for the green portion. Okay, so green region, which is A2. So A2 is basically the area between the graph parabola from 5 to 6, correct? And the x-axis. So once we find this area, by integration, just integrate it, limits from 5 to 6. And when you figure this out, calculations, right? Simple calculations, you do them, you get this as 7/3. So that is the green area. To find the orange area, which is the required shaded region, you take the difference of big area and the green area. And then you get your answer, which is 10/1/6 units squared.
All right.
Is that clear to you?
Yeah.
So can you summarize me the steps? We are going to follow exactly the same steps in the next 3 questions also.
Right. So we started off by just simply gathering our information from the question. Yes. So in this case, the graph was given, but we don't know a few points. So we started off by finding the X intercepts. So since it's a quadratic, we just simply factored it out, and you get x minus 1 bracket and x minus 5, meaning x is 1, 0, which is the point A, and point B is 5, 0. Yes. Then the line x minus 1 intersects with the f of x. So there's clearly a point of intersection at that top point, which we label as C. Right. So to get that point, you just make the 2 functions, f of x and g of x, equal to each other. Follow through, and you get x being equal to 1 or 6. Yes. But since we've already got 1 as being 1, 0, which is A, we know the other x-intercept is 6. Okay. Then you simply sub the x-intercept into one of the easier functions, so in this case g of x, and you get it as 6, 5. So yeah, that's the point of intersection. Now the key point to solve this question is putting the perpendicular line, which is so you said it was like a kind of like a projection. I like that because yeah, it's the same x-intercept. Yeah. So when you put a perpendicular line, that point there would be 6, 0. Okay. And we can start off by finding the area of the big triangle. Yes. So that's simply base times height divided by 2. So we got the 2 things between 6 and 1. So the base is 5, and we know the height is 5. 5 times 5 is 25. Divided by 2 is 25/2. Then to find the green part, we use integration, and you can see that it's in between the limits 6 and 5. So you just simply do f of x differentiated with respect to x, do all of that, and you get the area of the green part as 7/3. Perfect. Then to find the orange part, you just do the difference, which is a1 minus a2, and you get 0.1016 units squared.
Perfect. So it's absolutely clear, right?
Yeah.
Now, let's take the second example, try to understand this strategy. Can you please read the question number 2?
Yes. Question 2. The graph of f of x equals x cubed plus 4x squared is shown. Area under the curve above the x-axis is bounded by the segment BC, which is 30 units squared. Find the coordinates of C if point B on the curve is 1, 5.
Okay. So slightly, I've actually cut down on many steps of this example also. The idea is that we have this function f of x which is given to us. So the function f of x is given. So that is the cubic function which you can see here, right? So this is the cubic function. Now, a portion of this has been shaded in green. Now, this portion which is shaded is exactly not the area under the graph. We have an extended portion here. Like, you see this extended portion? I should say extended. Because area under the graph is from here to this only, correct? So BC is this particular line. This particular line of the triangle is BC, right? So we have an extra triangle added to the area under the graph and above the x-axis. Do you realize that part? So this is your x-axis. So the graph function is between this point, which is C. Let me write bigger C. C is given to us as 1, 5. So if I put 1 on the function f of x, f of 1 is 5, right? And so you have this particular point, which is C, 1, 5. So the strategy should be to find the whole area is to add area of this triangle to the area under the curve, correct? What do you think?
Wait. To find the area of the triangle.
So if I have to find the area of the graph under the shaded area, which is green area, what is that?
Yeah. The area you highlighted under there plus the triangle.
Plus the triangle, correct. So the first part of the area can be found by the integral of the function within these limits, correct?
Oh.
And the second part is the area of the triangle. Total
I had a
30 units square is given to me. So if I add them up, I get total area of 30 units square. With that, I can find what is this extra length. That is the whole thing. You get the idea?
Yeah, I had a similar question to this, like not the same, but like a similar one.
Right.
And if you know that point where it turns, like the turning point, the minimum
this point you mean?
part.
This point you mean? Yeah.
Yeah.
Yes.
I tried to find the area of that bit first,
yes.
Between those two limits, but I got it as 0.
Oh, okay.
Anyway. But then when I did it with the whole thing, even that little extra part right before the perpendicular line, I got a value.
Okay. We'll look into this area and then we'll discuss, okay? So let's look into the solution of this particular question. Now again, the graph of f of x equals to x cubed plus 4x squared is shown. The area under the curve above the x-axis bounded by the segment BC is 30 units square. So I have given full area of the shaded region, which is 30 units square. All the green area is 30 units square. Find the coordinates of C if point B on the curve is 1, 5. If we are given this point B as 1, 5, we have to find the coordinate of point C. Correct? So that's the question. So first step should be what? First step, begin with your function, find these x intercepts, correct? I mean, these x intercepts. We are already given point B. So basically these two x intercepts, which you can equate to 0 and figure this out. Is it okay? Yeah. X is common and then you can find this. So solution here is, let BD be a perpendicular to x-axis. So as we did in the last case, here also, what we are going to do is we're going to drop a perpendicular from B. So we can split it into two parts. One is area under the curve and the positive x-axis. The other one is the triangle itself. Now in the triangle, we don't know this length. So we'll call this length as unknown length BC, okay, or DC in this case. So area of this particular triangle is half base, which is DC, into height, which is 5. Is that clear to you? So we know this area.
Oh, yeah.
So let me show that first. So area of that portion which we are talking about is half BC into 5. So that is the second area. Now, first area here is between the graph and the x-axis, which you'll find by integration, correct? So we can integrate in one shot also. You can also split in two and then do it as you were trying to explain earlier, right? You could do that also. Your method is actually better since you get limit from -4 to 0 and then from 0 to 1. It's easier calculation. However, you realize, but you realize you have to find the value at -4 and you have to find the value at 1. For 0, it is 0. So basically, you have to find both the values, correct? So you could also directly do it. So we'll do the first part as integral between -4 to 1. And integral of this polynomial is x to the power of 4 over 4 plus 4x cubed over 3 within these defined lower and upper bound. So that is to say that you first put 1 here, so you get this part, take away, plug in -4, you get this part, correct? Now since 4 times 3 is 12, what I did was I took a common denominator of 12 itself and multiplied the terms, cross multiplied, wrote them, and found my answer as 275 over 12. Now this is a very easy way of calculating. So it really saves time. I know calculator is allowed in your test. However, if you write the information in this method, in this way, it helps you to check your solution also if you go wrong somewhere. But if you plug in all the values in the calculator, you will never know whether your answer is right or wrong, right?
All right.
So since you can observe that 12 is your common denominator, no need to simplify few terms even if you can. Why? Ultimately, there will be a term of 12 in the denominator. So put it there. And put the numerator there. Now use your calculator. Get 275 over 12. So that becomes area, part of the area. But what are we given? We are given total area, right? We are given total area of 30 units. That is what we are given. So what I found is I have to really find what DC is. The real question is to find the coordinates of point C. So I'm saying that the second area will be 30, take away A1, correct?
Just quick thing. What is 30 units? Like what area is it? Is it that triangle?
All green area. So 30 units square is basically all the green area, correct? We found a part of it. So if I take away from 30 that part, I'm left with the area of the triangle, correct?
Makes sense. Oh, okay.
That is what I'm doing. So
that's smart. Yeah.
Yes. So what I'm doing here is I'm finding the area of triangle as, let's say, big area minus A1, correct? So that's what I did. So 30 minus this area, A1, taking away 275 over 12, gives me a value 85 over 12, correct?
Which is the triangle.
So now I'm saying that the triangle area is this much, which is A2 for me, correct? So A2 is half base into height, which is 25 over 12. From here I can find what DC is. DC is 25 over 6. Now remember, DC is 25 over 6, but the point C is 1 unit further away because D is at 1, right? So
you add 1.
Still, there are a lot of things to incorporate to get exactly the correct answer. So you get C as 25 over 6. You get the point.
Yeah, that was really that's quite a good, nice question. Yeah.
Brilliant question. And many things will go, and there are different ways to do it. I mean, I'm not denying. However, I find this particular approach to be simpler with least amount of calculations. Otherwise, it's very complicated. You get it?
That's true.
Perfect, right? So
Yeah, like it.
yeah. So as you were saying, splitting into two parts is a good thing, not really required. If the complete graph is above the x-axis, it is not required. Even if it is zero in
Oh,
between, it has to be continuous and positive, then it is not required. But if it is negative and positive, you have to make absolute value of one portion. So it is required to split.
right.
Clear?
Also, I just checked again with the 0 thing, and it does work. I made a few errors.
Okay.
Yeah, it does work between the 0. I was thinking, why is it not working? It does work. Yeah, sorry.
Correct. So that's fine. Actually, strictly speaking, in this particular calculation, since we have done from 1 to -4, so the value which is this value -4, right?
Yeah.
1 to -4 will actually give you this portion of the graph.
Oh, yeah.
It will
Because
give you
that would be -4 to 0.
right.
Yeah.
So that will calculate to the value you're looking into. Now let's look into the next question, which is a very similar question. So I'd like you to read the question and tell me the strategy this time. Question number 3, please.
Okay. Question 3. The graph of f of x equals x squared plus 2, and g of x equals minus x plus 8 is shown. Graph intersect at -311 and 2,6. Find the area of the shaded region.
Correct. So we are given these 2 points of intersections, which is this point here and this point here. Correct. Find the area of the shaded region. The shaded area region here include red plus orange.
Oh, only red plus orange.
The shaded region which you see includes the red portion, which is between the parabola and the straight line, and then rest of the portion is between straight line and x-axis positive. Do you see that portion? So it is combination of these two. So what should be your strategy to get this area under the shaded region?
Sorry, just to double check, with the shaded region, is it the whole thing under the curve, or is it just that bit where they overlap? Or like the triangle section, did you put that?
It is from here, it is from this orange portion.
Yeah.
It is all this portion and this part of the parabola between a straight line and the parabola and this orange portion, a triangle.
Oh, okay.
You get the idea? Shaded region?
There's like 3 colors. Sorry. So, the triangle, you're saying?
Yeah. So it is, think like this. All this.
Oh, all of it.
Yes.
Oh, okay.
Yeah, because I overlap triangle on red and orange, so it gives you a different color.
Oh, yeah.
But it is all one. Okay.
So, so with this question, can we start with the area of the triangle?
Yes,
that seems easy.
Yeah. That's good. So you can find area of the big triangle here, right? Let's call some area A of triangle. Okay.
Yeah.
Very easy, right? You know this is 8, and you need the height is also 8, right? So area of the triangle is easy.
32.
So actually, I also did the same thing. Area of the triangle. Now you're left with only a small area of between parabola and the straight line. So you have to now consider area of this parabola, which is from -3 to 0.
To 0.
That is all. Do you see that?
Yeah, it's nice and easy. Okay.
So once you just do this area, you get the remaining shaded region.
Oh, and then you just add. Oh, that's good.
So the idea here is you have to split your portions of areas and see how to get which one.
Oh, right.
So,
okay. Yeah.
Yes, you have learned integration, but it's like sometimes, killing a bird with a cannon, right? So don't apply it too much.
Yeah.
Just selectively apply in the places where it should be applied and standard area formula for rest.
Makes sense, yeah. Because I think before, obviously, when I started, if I saw this question, you know, when you know that point between 0, like where the triangle
0 and
height
yes,
is.
the point of 2, 0 and 2, and they are
Yeah,
given you this point 2, 6 to misguide you.
yeah,
It is not required.
yeah. And I would be like trying, because I think I need to use integration. I'll be trying to find that part of the curve, and
Correct.
then like I wouldn't see it as a triangle and think that I can use that formula. I'll try and do all the integration stuff when it's not needed. Only use it when you need it. Yeah,
Perfect.
that's quite a key point.
So this is also a type of examination question which can throw you off. But if you really look into it, dissect, different parts, and then you do it, it becomes one of the most simplest question on this topic. Get the idea?
Yeah.
So let's move on. So we are focusing on where the figures involve area of a triangle, and you can isolate that triangle very easily to simplify your question. Last question here includes some surds, and that could be a difficult integration itself. So now, can you read this question?
Yeah. Question 4. The graph of f of x equals x to the power of 2/3 minus 2x to the power of minus a third plus 1, and g of x equals x minus 4 is shown.
Yeah.
Graph intersects at 8, 4. Find the area of the shaded region above the positive x-axis and between the curves as shown in blue.
Yes. So what I've done is shown in blue the real area which you want to calculate. Is that clear to you?
Oh, okay.
So when we say area of the shaded region, we have somewhere set positive x-axis and between the curve. Now, positive x-axis and between the curves means that particular blue area. In the examination, they are not going to tell you blue area. Is that clear to you? You have to understand a common region between the positive x-axis, that is above that, below the function, which is surd, and then a straight line. So that becomes your blue area. Now, how do you find this particular area, which is shown in blue? Tell me.
I don't know. I'm just guessing at this point now. Could we find, you know, that triangle? Like, if I just put a perpendicular line from the 8, 4 down.
Yes.
Could you do that?
Yes. So I have pulled this down, and so I have a triangle right there. Do you see that? Now this white triangle, this is additional. We don't need this. We have to throw it away. Correct? Now what I've done here is, first, of course, you have to find the x intercepts and point of intersections if they are not given. Right? I simplified the question by giving you all the values. Sometimes they're not given. So be prepared to solve this equation and get your x intercepts clearly. Is it okay?
Right, yeah.
So get ready for that. And then point of intersection between the line and the graph that you may have to find at times if not given to you. Okay. Now we have all these values. So what we are going to do here is we'll find the area between f of x and the x-axis. Big area. Do you see this area? We'll find the whole area. Only between the function f of x and the x-axis for the points given 1, 0 and the point of intersection, which is at 8. So I have the huge area now. But I don't want this triangle. So I'll take away the triangle, get blue area.
Yeah, okay.
Do you get the idea now? So very simple.
Makes sense.
Only one function to be integrated.
Just a quick question.
Yes.
Sorry, with the X intercepts, how did you get that again?
X intercepts equate g of x equals, the f of x equals to 0. F of x equals to 0. Then you have actually slightly more complicated because you have x to the power of 1 over 3 in the denominator, right? So multiply everything with x to the power of 1 over 3. You're getting my point?
Oh, to get rid of the,
You can do trial and error.
Wait, so how did you get 40 as well? Did you do the same method?
Oh, this is for the straight line.
Oh, okay. So the only points you found is 8, 0, and
So
1,
this is
0.
a straight line, correct?
Mm-hmm.
4, 0.
That makes sense to me. Yeah.
Correct. 8, 0 is perpendicular from this, so it has to be, x coordinate has to be same. So 8, 0.
Oh. Mm-hmm. Yeah.
Correct.
So then 1, 0, all you did was sub that, make that equation equal to 0.
Correct. So if you have a cubic equation, you do trial and error, right? You begin with 1, 2, 3, 4 and check. So you could do trial and error. Just find what is f of 1.
Okay.
You get this 0, and that is your x-intercept. So
Makes sense. Thanks.
That could be the best method. Remember, polynomials, you have to find a root first. Then you have to divide and get the quadratic and do all the needful, right? So you could do with the surds also the same thing. So if you plug in 1 here, clearly 1 minus 2 plus 1 is 0. So you get your answer if it is not given to you, right? So if this point is not given to you, which will not be given to you in the test, okay?
Yeah.
I'll give you a graph. Now, simple question. We have simplified rather. So we'll actually work with the integral to find the big area first. And from that, we'll take away the triangle area to get our answer. And now, then when you do this calculation, you may use calculator. At times, it may be very tricky to calculate 8 to the power of 5 over 3. Well, that's not very difficult because, 8.
It's cube root of 8.
Cube root. And then power is 5. Is that clear to you?
5.
It's 2
oh, yes, so 32.
Correct? And so this is equal to 32. So that is how you get 8 to the power of 5 over 3. So first you get cube root of 8, then you get the power and write down the value, right? As we have shown here in the calculations. So these are easy calculations to do. And once you put them, it's not very difficult to calculate the answer. You can cancel some values here, correct? You see that? And some numbers to work with.
Oh, yeah.
And you get your answer. Does make sense?
Did you subtract the triangle area?
Yeah. So this is the triangle area subtracted right here in the beginning itself.
Yeah. Oh, yeah. You did that really early on. Okay, yeah.
Yeah. Because it wasn't that bad, right? The triangle area is just a number which easily we could find, which is -8.
Mm-hmm.
So we could do it at later stage also. First find integral, no problem. First find integral, then subtract the area. You could do that. No problem.
Yeah, see, what threw me was the X Intercept for some reason, but now you've shown it's just simple. I don't know why that threw me, but it did. Yeah. Okay, so the surds look really complicated, but they're not actually that bad.
Yeah, they're not that bad.
Yeah. But also one thing, so how do you know how to draw an x to the power of 2/3 graph?
No, the graph will be given, but it will not be labeled. So graph will be given. Do you see we do not have any x and y values on the graph?
Yeah.
We don't have.
Also, we would have to find them.
You have to find them. They'll give you the graph. It gives you an idea that this is how the graph is going to look like. And this is the shaded region you have to find area of. But they will not give you the x intercepts. They will not give you the point of intersection. You have to figure them out.
Yeah, that's all right. It was just drawing the graph because, with the x squared you had previously, you had the -6x plus 5 one.
Okay, let's go through. Yeah, these are the questions which we worked, right?
Not this one. Oh yeah, the first one.
Yeah.
So even if that graph wasn't given, at least I know how to sketch it because it's a simple quadratic, But it's when it comes to the 2/3 and stuff, because I'm not that obviously confident with sketching. If it's provided, it's obviously easier.
All these graphs will be given to you as shown here in this particular page. So more or less, the graphs will be like this, where the scale will not be given to you, right? So you'll know that there are some x-intercepts and some points of intersection. You have to figure them out. Right? Yeah. Sometimes they may give you, for example, in this particular question, it makes sense to give you this particular point because from that point we have an extension. Since we have an extension here, we are interested in that portion. They could give you some other point, some other extension, some other area, right?
Right.
So that could complicate the question. However, the strategy is very clear that when you have a question like this, try to break it down into different regions. And if you find a triangle in between, isolate the triangle. That is my best.
Oh, okay.
Isolate the triangle, find the rest with integration, add or subtract your triangle.
Perfect. Yeah,
Because
that
with the
sounds great. Yeah.
x-axis, every line is perpendicular on x-axis. It's a half
Yeah,
base.
that's true. All right.
Is that all
Yeah.
clear to you? Right?
It's just so clear. Yeah. I
And
love integration now, so thank you for that. Yeah.
yeah, so Amy, I'd like you to summarize today's learnings and how this can help you to do better for GCSE Level A examination.
Mm. Well, I just love today's lesson for starters. I think the questions you've given have put honestly everything together from when we started from integration day one. And yeah, so I think today's lesson was more about use integration when you need it, basically. Don't try and use it just because you feel like you need to, because it's under the topic of integration. Main thing you said was section graphs and things into regions. That would make your working so much easier.
Yes.
Obviously, labeling them A1, A2 would obviously help. And then triangles are key. When you find a triangle, what Mr. Kumar said was keep it to the side and always exclude that. And once you get your triangles, because they're so easy to obviously find the area of, all the rest of them which are under curves and things, that's when you use integration, which obviously makes sense. And then, so when you find triangles, obviously there could be a question that could ask, maybe find the area of the whole thing, including the triangle, but then maybe later on it'll be like, just give me the triangle area. So it's good to like separate out the areas into sections. So that's very obviously easy to identify. And graphs are usually given, or are always given in integration questions, but you need to be aware that the X intercepts, other point of intersections and things won't be given. So you would need to find that, but obviously that's not too hard. Just making point of intersections, making functions equal to each other. And I think definitely reading the question, and when it says like, is between the positive x-axis and under the curve, knowing like the shaded region is key, because if you shade in the wrong region, then the answer is going to be wrong. So yeah, just understand the question.
Perfect. That's good. Excellent. So I think with that, everything is good. We can conclude our session on calculus, which includes both derivatives and integration. So all the best, Amy. Try questions from your book. Do some examination practice. And if there is any difficulty, you can always write back to me and we can work on that. Yeah?
All right. Thank you so much, sir. Really appreciate it.
Thanks a lot.
Thank you.
Thanks.
Bye.